Here we have a SAT math problem. Okay, let's go to the question. H of x equals to 5 times x negative m times x negative n times x negative r. The function h is defined by the given equation where m, n and r are distinct constants. When m is less than x less than r, the value of h of x is positive. The graph of y equals to h of x contains a point s comma t where s and t are constants. If t equals to 9, which of the following could be true? Here we have three statements and we have to find the one that could be true. Let's use Desmos to solve this problem. Let me give the given function h of x as input. That is h of x equals to 5 times x negative m times x negative n times x negative r. Okay, here we can click on R to get the sliders to fix the values for m, n and r. And there is an information over here, that is when x takes a value between m and r, the value of h of x is positive. That is the value of y is positive. That is when we have the value of x between m and r, the graph has to be above the x-axis so that y will be positive. That is h of x is positive. And from this inequality, it's clear the value of m is less than the value of r. Okay, now we can use slider and Desmos to fix the values for m and r so that m is less than r. Okay, here already we have the value 1 for m. Okay, now let me move the slider to get value for r so that it is greater than m. Okay, let me take r equals to 5. Okay, here I have taken m equals to 1 and r equals to 5. Okay, so that is 1 is less than 5. Okay, when x takes a value between 1 and 5, h of x, that is y is positive, that is the graph has to be above the x-axis. Okay, let's go to the graph in Desmos and consider the values of 1 and 5 on x-axis. So 1 and 5 are the values of m and r respectively. Okay, here when x takes a value between 1 and 5, we find the graph below the x-axis. So that is h of x is negative, but we want h of x has to be positive when x takes a value between m and r. Okay, what do we have to do? Now let's consider some value for n so that h of x is positive when x takes a value between 1 and 5, that is between m and r. Okay, what value can we take for n? Okay, here we have three possibilities to take a value for n. That is, we can take a value for n so that it's on the left side of m, that is less than m. Or we can take a value for n between m and r. Otherwise, we can take a value for n to the right side of r, that is greater than r. Okay, now let me take some value for n over here so that it is less than m, that is to the left side of m. Already we have m equals to 1. Now let me take some value over here which is less than 1, that is which is less than m. Let me move the slider to the left side. Okay, here I have taken a value for n negative 2.2 which is less than 1, that is we have this value to the left side of m. Okay, in that case, here we find the graph between 1 and 5, again below the x-axis, that is h of x is negative. So when you take a value for n to the left side of m, so h of x is negative for this interval of values of x. Okay, now let's take a value for n so that it's between m and r, that is between 1 and 5. Okay, let me move the slider over here. Okay, here I have taken n equals to 3. So the 3 is a value between 1 and 5. When I take a value for n between m and r, okay, here I find the part of the graph above the x-axis and part of the graph below the x-axis. That is, in the interval of values of x over here, for some values of x, h of x is positive, and for some values of x, h of x is negative. Okay, now let's consider a value for n so that it is greater than r to the right side of r. Okay, now let me move the slider over here for n to get a value so that it is greater than 5. That's a value for r. Okay, here I have taken n equals to 6, that is greater than 5. That's a value of r. Okay, when n takes a value 6, that is to the right side of r, between 1 and 5, I find the graph above the x-axis over here, that is h of x is positive. Okay, so when n equals to 6, that is above the value of r, it satisfies the condition we have over here, that is h of x is positive. Okay, now let's consider the other information. The graph of y equals to h of x contains a point s comma t where s and t are constants. If t equals to 9, which of the following could be true? Okay, in this point, s is the x coordinate and t is the y coordinate, and we have the value of the y coordinate, that is 9. Since we have the value of the y coordinate 9, let's plug in y equals to 9 over here. Okay, y equals to 9. When I plug in y equals to 9, I am getting an horizontal line over here to the value 9 on the y-axis. And here this s is the x coordinate. Okay, now let me get the corresponding x coordinates. That is the value of x. Okay, let me click on over here and here and here. Okay, so when t equals to 9, we have three possibilities on the graph of the function y equals to h of x. That is, we can have this point s comma t over here or here or here. So that is, we have three different values for the x coordinate. That is the value of s. Okay, now let me write the different possible values of s. That is s equals to 1.09393. It keeps going. Okay, let me round this value to the nearest hundred. Then we get s equals to 1.09. And when I round this value to the nearest hundredth, I'm getting 4.64. And when I round this value to the nearest hundredth, I'm getting 6.27. Now let's consider the three statements we have over here. Let me take the first one, that is n is less than s. Here in Desmos we have n equals to 6. Okay, let's consider the three different possible values of s. So the first one is 1.09. Okay, when you consider the first value of s, clearly the value of n, that is 6, is greater than this value 1.09. But here the first statement says n is less than s. But here we are getting the result n is greater than s. Even for the second value of s, n is greater than s. Only for the third value of s, n is less than s. So here for one particular value of s, this statement is true. For the remaining two values of s, this statement is not true. So we are not able to conclude whether the statement 1 is true or not. So let's reject this one. Now let me take the second statement, that is s less than m. We have m equals to 1. Okay, let me write m equals to 1. Now let's compare the value of m over here and the three different possible values of s. Okay, for all three different possible values of s, the value of m over here is smaller. That is m is less than s. But the second statement says s is less than m. So it's not possible. The second statement is not true. We can reject this one. Okay, let's consider the third statement, that is r is less than s, less than n. Okay, here we have r equals to 5. Okay, now let me write this inequality with the value of r and the three different possible values of s and n equals to 6. Okay, so here let's take r equals to 5 less than, then we have s. S means let's consider the first value of s, that is 1.09. Okay, less than, the value of n is 6. Okay, even in this one, we can decide that the first value of s does not satisfy this inequality because 5 is less than 1.09. So it's not true, it's false. And we don't have to verify with the other values of s, because even if other values are satisfy this inequality, we cannot accept this. Because if this statement is true, it has to be true for all three different possible values of s with the values of r and n we have over here. So the third statement is not true. We can reject this one. Okay, in the given three statements, and none of them is true. We find none of them in answer choice D. So the correct answer choice for this question is D.